Hello students, today's agenda is to check homework. We'll be learning about equations of perpendicular and parallel lines, and you will be able to work on 11.10. Today, students will be able to find lines perpendicular and parallel to a given line passing through a given point. So before we do that, let's start with a warm-up that will help us for the lesson. And what I want you to do is to actually find the slope of each of these equations. Okay, so you want to pause the video and then come back. So okay, so the slope here, when y is by itself before the equal sign, the slope will always be the coefficient of x, and it's represented by m because this is in the form of y equals mx plus b. What that means is that it's the slope intercept form. Okay, so m in this case will be 2 because that's the coefficient of x. Remember that when we graph it, it's your rise over run, meaning this goes up 2 and then 1 to the right. Okay, the slope for the second one is negative 3/2. That means because it's negative, it's going to go down to 3, 2 to the right, 3 down, 2 to the right, 3 down, 2 to the right. The slope for the third equation, and remember, it's only as easy because y is by itself. So in here is 2/3. For the fourth one, my slope will be 2. And finally, for the last one, the slope will be, okay, when some people say, oh, it's x or negative x. No, how come we're not using the x in here? Well, we shouldn't use x in here either. So my slope will be negative. And remember that if there is no number, then it's a 1. So negative 1. Okay, so something that I want you to recall from previous lessons is about what we're going to learn today, parallel lines and perpendicular lines. So if you recall, parallel lines. So for parallel lines, the slopes are the same, okay? Slopes of the lines are the same. So in here, if you look at all these equations, which two lines, if we graph them, will be parallel? Well, you have a 2 in here and a 2 in here. Oh, don't mind my Rocky. Hi, Rocky. So this is a 2. This is a 2. So those are the same line. Those lines are parallel. Okay, this line is parallel to this line right here. Okay. Also, for perpendicular lines, slopes are opposite reciprocal. So opposite means they don't have the same sign, and reciprocal means that the numerator and denominator changes. So what do you notice about these two? Well, this is negative, this is positive. In here, the 3 is in the numerator. It's 3/2, and in here is 2/3. Okay, so we can say that these two lines are perpendicular to each other. Okay, now let me graph them, and I'll graph the ones that I already know. We already know that are parallel to show, even though it's not part of this lesson, but we can really fast kind of sketch them. Okay, so this one is, it starts at 3. So 1, 2, 3. Remember that that's the initial point on Y, and then it rises and runs. So rises 2 and runs 1. So that's my first line. The other one that looks like that is this one. It has the same slope. So it starts at 1, then it rises 2 and runs 1. So it goes up 2, and then it goes to the right 1. And you can see that the lines are parallel, okay? They don't meet. Now let's sketch, let's sketch the other ones. So these two. Okay. And so the first one is starts at -1. Remember, this is, somebody said, oh, so this is y, y, x. Yeah, you can see, you can say that, okay? You move this on y, and this on x. So -1. And then it goes down, because this negative, you are going to give it to only one of the two numbers, not both. And you can give it to any of the two, it doesn't matter which one, but it has to be only one of them. So it's going to go down 1, 2, 3, and then 2 to the right, 1, 2. Okay, so my line is like that. I know it's not perfect because it's just a sketch. Now for this one, it's 1/7. Okay, it doesn't mean it goes up 1 and 7 to the right. No, it just means out of a hole, you just go up 1/7 right there. Okay, very close to 0. And then you go up, both are positive, so up 2, so something like that, and then 3 to the right, 1, 2, 3, so somewhere in there. And so my line goes through those 2 points, this point and this one right here. So you can see that they do form a right angle in there. Okay, so these are parallel lines. They have the same slope. These are perpendicular lines. They have opposite, and then reciprocal slopes. Okay, so that's going to help us for our lesson. Let's start with the first one. And so this is the first example. So it says, find the equation for the line passing through the given point and parallel to the given line. What does that mean? If they are parallel, that means that the slope has to be the same. And they're giving us the point that the other line passes through. So all you're going to do is just use the same slope because they are parallel, same slope. So what's the slope? 2/3. And the line will pass through that point. Okay? So now we're going to forget about this equation because that's the equation for another line. We're just looking for the line that is parallel to it. We ignore the 5 because that's one of the questions that came up. What about the 5? We just ignore it. That's just part of a different equation. We're looking for the one that is parallel to that one. Okay, so remember the equation is going to be y minus y1 equals m times x minus x1. And we proceed to replace. Remember, this is m, so it goes here. Then you have this right here, which goes on x1 because this is x1 and y1. And finally, this goes right here, okay? Because this is y1, this is y1. So now we are going to replace y minus 9 equals m, which is the slope, 2/3, times x minus x1 is 3. We do distributive property. And property. And so we have y minus 9. 2/3 times x is 2/3 x. Positive times negative is negative. and then 3 times 2, 6, divided by 3, 2. Finally, if we're subtracting 9, the opposite is to add 9 to both sides. And so my equation is y equals 2/3 x, different sign subtract, and we get the sign of the biggest one. 9 minus 2 is 7. Okay, different sign subtract and get the sign of the greater one. So what does that mean? You just found the equation of a line that is parallel to that. So if you were to graph both of them, and I'm gonna do it right now, but you don't have to do it for the assignment. I forgot to put here cancel by adding. So I'm gonna grab it, but you don't have to do it for the homework, okay? Okay, so this is the lines that I'm gonna graph, the one that they gave us and the one that we found, so that it will be parallel, okay? Okay, so in here it says the initial point is 5, so 1, 2, 3, 4, 5. Then it goes up to 1, 2. Don't put the point in there. And then line is 3, 1, 2, 3. So right there. Okay, that's my first line. Okay, the next one is at 7. So 1, 2, 3, 4, 5, 6, 7. Then you go up 2, 1, 2, and then 3 to the right, 1, 2, 3, somewhere in there. And as you can see, with a lot of imagination, these are parallel lines. Remember, these are sketches, so okay, but they are parallel line, and you just found that. Remember, if it's parallel, use the same slope and the point that they're telling you that line, other line goes through. So this line goes through, if you notice, this is point 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, right there, 3, 9, okay? Let's do another example. So for parallel lines, use the same slope. Now in here, this other example, they're asking, find the equation for the line passing through the given point and perpendicular to the given line. So now, the slope, what do we know about the slopes of perpendicular lines? Okay, not only are they supposed to be opposite, meaning if this is positive, this will be negative, but also the reciprocal. Remember, for perpendicular is opposite, reciprocal. So the reciprocal of 3, you have to switch numerator and denominator. If it doesn't have a denominator, we put it over 1, and then that's when we swap them, okay? So it's going to be negative 1/3. And you just bring down the point. You don't need to bring it if you don't want to. You can just use that point, and that's it. And we're ready to use. Now remember, perpendicular means that they make 90-degree angles. Okay, so y minus y1 equals m times x minus x1. We replace, so this is my x, this is my y, and the slope is right here. Okay, so that's what we're using. Oops, I just grabbed those instead of this one. And in fact, I should be. So this is the slope. This is my x1. And this is my y1. Okay, so y minus y1, so it's minus 0, equals m is negative 1/3. Don't go over there, sorry about that. And x minus x1 is 3. We do distributive property, and we get, in here, we don't even have to bring down the 0. It's y minus 0 is just y. And then negative 1/3 x, because negative 1/3 times x is negative 1/3 x. Negative times negative is positive. And then remember that when you have a fraction and a whole number, if the whole number is a multiple of 3, or of the denominator, you can just multiply. 3 times 1, 3. Divided by 3, 1. Okay, or you can just do it on the side, -3 times negative 1/3 times -3, put it over 1, and then you just multiply straight. So negative times negative becomes positive. 1 times 3 is 3, 3 times 1 is 3, and 3 divided by 3 is 1. Okay, that's how you get it if you want to do the whole process with the fractions. And if not, that's it. Okay, in this case we don't have to cancel anything because we're subtracting 0 only. Okay, again, you don't have to graph them, but I just want to show you how the two equations look. Oh, my Rocky, he wants me to go and play with him. Okay, so in here, -1 is the first point, and then you go up 3, 1, 2, 3, and 1 to 1 run. So that's my first. Whoops, kind of like that. Okay, the other one is +1, then -1 means it goes down 1, and then 3 to the right, 1, 2, 3, right there. So that's the other line. And as you can see, they form perpendicular lines. Okay, I'm gonna do one more example, but if you get it, you're ready to go ahead and work on the homework. Remember, very important, for the perpendicular lines, you have to switch them and you have to change the sign. Okay, for parallel lines, you don't need to change anything. And I think I just want to show it one more time so that the slope is exactly the same. You don't change the sign, you don't change the numerator and denominator. Parallel lines have exactly the same slope. Perpendicular lines have opposite reciprocal slopes. Let me give you one more for the perpendicular lines. So that means that my slope is going to be the opposite. So instead of negative, it's going to be positive, and 3/2 is going to become 2/3. And now the point is 3, 1. Okay, again, we're looking for a line that if this is going like this, then the other line will be meeting it the other way and exactly forming 90-degree angles. Okay, so again, we're going to start with y minus y1 equals m times x minus x1. I'm going to replace my y, my m, and my x1. I'm not going to use colors for this one, but y minus y1, so remember this is x1, y1, so it's going to be 1 equals m is 2/3 times x minus x1 is 3, and I'm ready to remember what's the next step? Distributive property. 2/3 times x, 2/3 x. 2/3 times -3. Remember, if this is a multiple, if the whole number is a multiple of the denominator, you just multiply and divide. Okay, so 3 times 2, 6. Divided by 3, 2. Minus 2, because positive times negative is negative. In here, if we're subtracting, the opposite is to add 1. And y is equals to 2/3 x. Now in here, remember, if the signs are different, we subtract and leave the sign of the bigger one. Okay, so negative and positive, we subtract, and the bigger one is negative, so we're gonna get a negative, and 2 minus 1 is 1. Okay. Again, quickly, I'm gonna graph it. You don't have to. So it's gonna be 5, and then you go down 3, 1, 2, 3, 2 to the right, 1, 2. Oh my goodness, that's kind of far, but it's okay. The other one is -1 is the first point. You go up 2, 1, 2, and then 3 to the right, 1, 2, 3. So my lines are gonna be kind of like that. Whoops. And I guess my sketch is really off because of this separation, but with a lot of imagination, that's a 90-degree angle. Okay. Okay, so now you're ready to complete assignment 11.10 and have fun.